Then we check the next one, find the derivative. For the function given, f of x equal x squared times square root 1 minus x squared. Right, we could put a little small multiply to distinguish between that x squared, that's the square root that. Right, so this one is the product of two expressions, which when we do that, we need to identify the u and the v. Right? The u is x squared, v is square root of 1 minus x squared, which u is simple, the v is a little harder, right? So we need to take more care about the v, that's 1 minus x squared to the 1/2 power. U prime is simple, that's just 2x. V prime is 1/2 times 1 minus x squared to the negative 1/2. Right, but still need to multiply the derivative of inside. That's 1 over 2 square root 1 minus x squared. If I do it a little faster, right, that will be flipped down to the 1/2 at the denominator and become square root. And multiply by the derivative of 1 minus x squared is negative 2x. So we get v prime to be negative x times negative x over square root 1 minus x squared. The 2 and negative 2 being cancelled, only negative sign, the x is left over on the numerator and we have on the denominator. Right, so therefore, right, that's all u and the v and u prime v prime. Therefore f prime of x to be u prime times v plus v prime times u. 2x radical 1 minus x squared minus x cubed over radical 1 minus x squared. Right, if you want to simplify, you could find the least common denominator of radical 1 minus x squared and multiply. I get 2x minus 2x to the third minus x to the third, that's 2x minus 3x to the third over the denominator, right? So when we multiply the radical 1 minus x squared on the top and bottom, that's what we do, and we will get the thing underneath the radical. Right, so that is what we get for the derivative of this expression. Which, in short, right, to find the derivative is doing step by step of if we have composite functions. I find the derivative for the function f of x equals sine 2x times e to the 3x. Well, we still need to use the product rule, right? Since basically they are product. So after we identify, we need to figure out what to do. Right, the u is sine to the 2x, sine of 2x, the v is e to the 3x. U prime, the derivative of sine is cosine, and inside variable is 2x, so derivative of 2x is 2. Right, similarly, that v prime is to find derivative of e to the 3x, and what we can do is, well, e to the 3x is the derivative, same thing, but for the power 3x we need to find its derivative. Right, so that is e to the 3x times 3. Right, that we get 3 e to the 3x. So f prime of x is u prime times v 2 cosine 2x times e to the 3x plus v prime times u. Right, looks pretty much good enough. Maybe we write in the expression of what is given the trig in front and exponential afterwards. Right, to get a little nicely balanced of what it is. Right, so that is the derivative of sine 2x e to the 3x. And maybe, or from those examples, I believe we'll have some idea, right, how to apply the chain rule. Doing one by one, step by step, differentiate. Also, the next formula, the derivative of ln natural log right, is 1 over x for x to be positive. Right, that is because the domain of natural log, right, only takes the value to be positive. We can prove that. Let y to be natural log of x. So if we apply the base to be cancel them, or apply the inverse function, we'll get e to the y equals x. Then since we apply the derivative of e to the y, that we get applied chain rule is e to the y times dy over dx is the derivative of x respect to x is 1. Right, so dy over dx and e to the y is by the first step is x. Then we find dy dx is e to the x, is 1 over x. That we see the ddx of ln x is 1 over x. Right, and that's most commonly accepted formula. Another formula is more general, that the derivative of natural log of absolute u is equal to u prime over u, where u is some function of x. Right? When we apply the absolute value, it has to be positive. And by the definition, you cannot be zero under its domain. So this one true for everything. So you can try to prove it by separating the u first. I'd like to try to prove this general formula for the natural log. This is not that much widely used, but it is true for that we'll use this property in your calculus 2 course, right? But not touch that much in our calculus 1 course. In our differential calculus, not touch much. Right, so what we have seen the power rule, we have seen the trigonometric function, 6 of them, we have seen the exponential e to the x, we have seen the ln of x, right, the derivative of them. Then of course, if the x is not the variable, if the inside of ln is a variable u, then we need to have 1 over u times the derivative, right, of the inside function. I'll use logarithmic properties as aids to differentiate. I mentioned about the logarithmic properties, right, when we're doing the review session. We say that, well, inside the logarithmic, multiplication becomes sum of log, division inside becomes the subtraction of logs, and the power become the coefficient, right? That's all the properties we have. So we can use that property, right, to differentiate. F of x given is natural log of radical x plus 1. We are able to do the direct logarithmic. Of course, it's not a problem, right? We can have a 1 over radical x plus 1, then we take the derivative of radical x plus 1. That is, of course, not a trouble, right? It is fine. But if we apply the property, it will be a little easier, right? Sure, I could, if you want to see, I could show you the both way. F prime of x will be the 1 over square root of x plus 1 multiply the derivative of square root of x plus 1 multiply by 1/2 times x x plus 1 to the negative a half, multiply the inside derivative, right, the inside derivative is 1, that we get is 1 over 2 times x plus 1 on the denominator. Right, to dealing with the power is much struggle, right? It's a little more struggle. We will see what it means a little more struggling, right? If we compare simplify f of x first, that's natural log of x plus 1 to the half. That exponent become coefficient. To simplify, right, the properties. Then f prime of x is just 1/2 times 1 over x plus 1 times the derivative of x plus 1. Derivative of x plus 1 is 1. If you want to show it, right, that's 1 over 2 x plus 1. A little bit, or it's like very extremely easier than the way that we keep the radical as power. That will be more work to do, right? Even here I skip some steps that flip the power down and make power become the radical, right? But here we are not dealing with any radicals. The power 1/2, we just leave it in front of the log as coefficient, then it becomes much easier. And that is using the log property. And things could be more tough, right? Let's see something else. A natural log of tangent of x over 2. Then this one is log of tangent. Tangent x over 2 is just a function we cannot separate the unused property, right? That's just a single term basically. That what we can do is nothing else but just take the derivative. Natural log of inside, that will be the 1 over the inside. If we show steps that we need to take the derivative of tangent, derivative of tangent is secant squared. And we still need to take the derivative of x over 2. Right, since inside is a composite function, right? Since this is a composite of secant and x over 2. So we need to take the derivative of x over 2. Right, when we see, well, if we record the formulas we give, right, the sine, cosine, tangent, cotangent, secant, and cosecant, anything next to each other, we are able to divide and get a new form. Secant over tangent is the form of cosecant. Right, so secant over tangent is cosecant of x over 2. And the leftover 1 secant of x over 2 times 1/2. Right, so at the end we'll have simplified a little bit, right? Secant x over 2, cosecant x over 2. I'll have secant x over 2, cosecant x over 2 as the result. Of course, again, right, if you leave answer like secant x over 2 squared over 2 tangent x over 2, that is fine. Right, still absolutely correct. Right, we're just trying to simplify a little bit to make sure of that the function is clean enough. Right, if in case we need second derivative, this expression is a little more easier to differentiate than this expression. A little more clean, basically. Right. Right, so for this logarithmic expression, right, if we directly use formulas to do, I don't know if you want to do them, but I don't. It is not only hard, but it's nightmare. It's 1 over that expression, multiply the derivative of this expression. We have the quotient rule that takes the derivative of this expression, which is still you need to apply the power rule of that. Then the denominator, we still need to apply something called chain rule to do that, which is not that hard to do on the denominator part compared to the top, right? Then the entire jump piece will be very, very stressful to do, right, I believe. Then, at this time, right, maybe apply the property will be a little easier, right? Let's see. So f of x, we simplify that. The natural log of everything multiplied become adding together, everything dividing become subtracting, right? In other words, if we have the term on the numerator, the coefficient in front is positive. If we have the term on the denominator, the coefficient is negative. Right, so that we separate the natural log of x plus natural log of x squared plus 1 squared minus natural log of 2x cubed minus 1 to the 1/2. Right, that first, well, we have terms to be separated. Then the coefficients are coming from the exponent of them. Right, so the first term we have natural log of x, it's okay. The second we have power 2, take that in front of the term x squared plus 1. We cannot able to separate the this term since that's two terms adding together. The exponent is only applied to the x here, so no more we can do. Similarly, we have 1/2 natural log of 2x to the third minus 1. We get the product and quotient become the linear combination, which usually the linear combination are easier to do. Linear combination means the combination of log has the adding or subtracting together with the coefficient as scalars. Right? Then to find the derivative, f prime of x will be 1 over x. I could try to do a little faster, I can observe. 1 over x times the derivative of x is simply not need to show, right, since that is an x. Twice of 1 over x squared plus 1 multiplied by the derivative inside is 2x. 1/2 of 1 over 2x to the third minus 1 multiply the derivative of inside is 2 times 3x squared. Well, I could show that in one step, right? The derivative of x squared plus 1 is 2x. The derivative of the denominator 2x to the third minus 1 is 2 times 3x squared. So we get 1 over x plus 4x over x squared plus 1 minus, we have 2 and 2 cancelled, we get 3x squared over 2x to the third minus 1. We get 3 quotient. We do not have to combine all of them together since all this quotient is good enough, right? That is the natural log. Some other formula. I don't know if you consider or no, right? So we have touched the exponential function to get only e as the base. We get the logarithmic function also has e only as the base using natural log, right? But other bases are also appropriate, right? As long as they are positive and not 1. So the derivative of a to the x is a to the x times natural log of a, which the ln I write it afterwards is because if I write ln as coefficient a to the x is more confusing of what that is, right? So that's the only case that's the coefficient or scalar is multiplying afterwards the expression. And the log as a base of x has the derivative of 1 over x ln a. Right, so try to prove that. This logarithmic factor and the exponential factor. Right, the fact let a to the x equals y, x equals log a base of y. So I'll figure out the facts later, but try to prove them. I'll give you a simple hint right later for both of them. Right, so try to prove them. Basically, it will be related to some expression e to the or so. Right, we will relate it to that. And then this one will relate it to something like log of x of log of a, right? Something like that will be related. So you can use the property of them to try to prove them. Yeah. But they are the formulas, right? Instead of simple logarithmic, we have the coefficient attached to it. Now when we observe them carefully, that we have the if the base is e, that's e to the x. If base is not e, that's same a to the x, but need to multiply scalar of ln a. For the natural log, is 1 over x if the base is not e for any arbitrary a, not arbitrary but any a appropriately, that's 1 over x times ln a. Right, so when we observe the formula, they just have additional coefficient next to it, which is just the general form, right, of the exponential function and logarithmic function. So to differentiate 2 to the 3x, we get y prime to be 2 to the 3x multiplied by L into. Alright, that's first thing. The derivative of exponential function is exponential function itself times the natural log of the base multiplied by the derivative of 3x, right, since that's composite function. Usually we write coefficient in front, 3 times 2 to the x, ln 2. Or if you keep that 2 to the x times ln 2 times 3, that's fine. But just in that way is also okay. Right, to find the derivative of the next expression, right, 5 to the x plus cosine x. Right, so the derivative, right, to find it is same as exponential function. Just to copy down the term f prime of x will be copied down 5x plus cosine x times natural log of 5. Right, that's just a little coefficient attached to it. Then multiply, the term is the derivative of x plus cosine x, since that is our power. 5 to the x plus cosine x ln 5 multiplied by 1 minus sine x. Well, just leave that long expression, is fine. We just have natural log 5 as the coefficient. And to write it in the middle is fine. If you want to attach it in the front is fine, and so on. That's the product of two different expressions, and the expression has different base. We're able to do them by identifying the u and the v. U prime is simply that 3 to the x natural log of 3. And the v prime is 2 to the tangent x natural log 2 multiply the derivative of tangent is secant square of the variable x. So that is what the v prime is. Right, then to write everything together, f prime of x is u prime v plus v prime u. Well, no matter which order you want to keep it, right? Keep them. You could keep like the same order provided in the question: 3 to the x, 2 to the tangent x, natural log of 2, 3. 3 to the x, 2 to the tangent of x, natural log of 2 times secant square of x. And still we have the common factor of 3 to the x, 2 to the tangent of x if you want to see, right? But that, you could rewrite it into this format, leave like the original is nothing wrong, right? It's also fine. Right? Oh, let's see the next example about the logarithmic. Log 7 of cosine 1 over x. Alright, so the derivative, right? Apply the formula that it will be 1 over x times natural log of a, right? We have the base is 7, so the derivative will have an extra coefficient on the denominator, nothing else but just that. F prime of x is 1 over cosine of 1 over x times natural log of 7. Multiply the derivative of cosine if I show the full step, right, you'll see the derivative of cosine is negative sine. 1 over cosine times negative sine of 1 over x. Multiply the derivative of 1 over x. Negative sine of 1 over x over cosine of 1 over x times natural log 7. Multiply the derivative of x to the negative 1, that's negative 1 x to the negative 2. Alright, so we have negative cancelled, we get tangent of 1 over x over natural log of 7 multiplied by 1 over x squared. A negative cancel, sine over cosine is tangent, we still have natural log 7 on the denominator, then this term x to negative 2 flip down to be 1 over x squared. That we get at the end is tangent 1 over x over x squared natural log 7. Right, that's this expression we have. Well, similarly, the log property is still appropriate to this one. Right, we are able to simplify it. That's log 5 base of radical x minus log 5 base of x plus 5. Right, the power become coefficient, subtraction, multiply become adds, dividing becomes subtract of the format. Then then do the derivative. That's 1 over 2 times 1 over x natural log of 5 minus 1 over x plus 5 times natural log of 5. And the derivative of inside, if you want to show it, it's 1 and 1. Right? The derivative of x is 1, the derivative of x plus 5 is also a 1. And then to combine them together, that's 1 over 2x natural log 5 minus 1 over x plus 5 ln 5. Right, to write this expression is good enough. Right, so apply the formulas of them, and next time we will see some something a little tricky, right? A little tricky derivative, which is wrap up every exponential function with logarithmic functions together with the product or quotient rules. I will see them later.